Hello everyone, welcome back to Knowledge Bytes. And in previous videos, we learned about the neural networks, perceptrons, and weights and biases. Today we are going to one step deeper, which is after a neuron receives inputs, applies the weights and add the bias, it gets a final value. But important question is, should this neuron activate or not? That decision is made by something called an activation function. In this episode, we will learn about the Sigmoid, Tanh, ReLU, non-linear, and real-world examples, along with the AWS AI practitioner style questions. Let's get started. Now, what happens inside a neuron? So a neuron receives the inputs and from the other neurons, right? So each input is multiplied by a weight, then all the weighted values are added together. Then after that a bias value is added. So the neuron now has a number, but what should it do with the number? Should it pass to the signals to the forward or should it stop the signals? This is where the activation functions comes in. So think of it as a decision maker or gatekeeper, right? So it decides whether the neuron should activate or send the information to the next layer. So now the next question comes up, what if we remove the activation function? So now imagine a neural network without the activation function. Even if we add many layers, the network will still behave like a simple linear model. So that means it can only learn straight line patterns. But in real world, data is not always the same. Imagine speech or images recognition system or speech recognition system or fraud detection system or medical diagnosis system or language understanding system. All these complex problems without activation functions, neural networks cannot learn these complex problems, right? So activation functions are not optional, these are essential. Now, so the power of non-linearity. So the biggest reason we use the activation function is to add the non-linearity. Linear means simple straight line relationship. Non-linearity means complex curves and patterns and relationship, right? Real world AI problems are mostly non-linearity. So non-linear problems. For example, for recognition needs to understand the shapes, angles or features, right? The speech recognition needs to understand the tone, accent and sound patterns. The same way, the self-driving cars needs to understand the roads, objects and the movements, right? So ChatGPT needs to understand the language and context. Activation functions helps neural networks to learn these complex problems. That is what makes the deep learning powerful. Now next get into the sigmoid activation function. Let's start with the sigmoid. Sigmoid takes any input value and converts it into the number between the 0 and 1. For example, if the input is very negative, so for example, if the input is very negative, the output is close to the 0, right? If the input is 0, the output is 0.5. The input is very positive, the output is close to the 1 because the output is between the 0 and between 1. So sigmoid useful to probability based on the predictions. For example, in this email spam, so for example, is this email spam or is this patient risk or will this user click an ad or not? However, sigmoid had the limitations, right? So this is where the sigmoid works. For example, so it runs between prediction between the 0 and 1. So it gives the values between the predictions. It's a 0 and 1. If it is a most predictable value near to the 1 or the less predictable value near to the 0. That's where. So, however, the sigmoid has the limitations. In deeper networks, it can slow down learning because of its a vanishing gradient problem. It has a vanishing gradient problem, right? So this is where the modern deep learning often uses the other activation functions, which is now we are going to get into the Tanh activation function. So Tanh stands for hyperbolic tangent. So it is similar to the sigmoid, but its output range is different. Sigmoid output value is 0 to 1, which we learned in the previous slide. Tanh output value from -1 to +1. This is useful because the Tanh is centered around the 0. Negative inputs produce negative output, positive inputs produce positive output, and 0 input produce 0 output. Because it is the 0 centered, Tanh can sometimes help models to learn better than the sigmoid. That's very important. So, but Tanh can still suffer with the vanishing gradient problem, right, in the deeper networks. So, to researchers needed something faster and simpler. That brings us to the ReLU. ReLU is very important. Now let's get into the ReLU. ReLU activation functions basically. So let's get into the actual details. ReLU stands for the rectified linear unit, meaning it is one of the most common used activation function in the modern deep learning systems. So ReLU is very simple. If the input is positive, ReLU keeps it as it is, right? And if the input is negative, ReLU changes it to 0. For example, input 5 gives is as a 5 because it keeps as is positive value. If it is a 0 keeps as is, and it becomes a output is 10. So right, if input is 10 and the output is 10. If it is a minus values, let's take -3 is the input, then it gives the output as a 0. This simple rule makes ReLU is very powerful. It is easy to compute and fast to train and works very well in the deeper neural networks. So now the question, why ReLU become popular? So why did ReLU become popular? Because first, it is the computationally simple. Second, it helps deeper networks train faster. And third, basically, so it reduces the vanishing gradient problem compared to the sigmoid and the Tanh functions. Fourth, it performs well in the many real-world deeper learning models. This is why the ReLU is widely used in the modern AI systems, especially in the hidden layers. We talked about the hidden layers, how it is predict the values or the decisions, right? So that's where the ReLU is useful. Okay, now you will see ReLU is computer. Basically, you will see the ReLU is computer vision and image recognition system. It is used in the computer visions and image recognition systems are deep neural networks, right, and many more in AI models, right? So now comes to the next part. So the AWS AI Practitioner, for AWS AI Practitioner, the question level, so ReLU is the go-to activate function for many modern deep learning models. So most of you may get the question from the ReLU, right? So now get into the activation functions in the action. Let's understand this with a image classification example. So suppose we give a cat image to the neural network, right? The first layer may detect its edges first, and some neurons activate because they see useful edge information, right? And the second layer may detect shapes. Again, only important neurons activated. But the next layer may detect the features like ears, eyes, and whiskers and fur patterns, right? Everything. So finally, the output layer predicts that this image is a cat. Activation functions help the neural network to decide which signals are important and which signals should be ignored. That's where the important, because see, in our example, we learned that few activation functions, which is detecting the edges, detecting the patterns, right? So which is important, which is not important, that's where deciding factors. So without activation functions, the network would would struggle to learn complex visual problems, right? This is why the activation functions are gatekeepers of deep learning. Now get into the next one. So this is where the activation functions work out, but now get into the important point is the AWS exam corner. So that's where we are going to learn how it is going to be covered in the AWS pattern exam. So let's get into the first question. So which of the following is the primary purpose of an activation function in the neural networks? The answer A, store training data. Answer B, add non-linearity to the model. Answer C, increase storage capacity. Answer D is replace weight and biases. So we every time talked about how we can ignore the answers first if you don't know the direct answers. For example, the answer A talks about the storing training data, which is not right to here. It is not about the storing, right, data. So now let's get into the next B. Okay, let's ignore the B and C. Look at the C, increase the storage capacity. It is talking about the storage capacity. So activation function is not talking about the storage capacity or replace weights and the biases. It's purely talking about the add non-linearity to the model. So the answer B is correct. So basically the activation function introduces non-linearity, which allows neural networks to learn complex problems. Now let's take second question. So which activation function outputs value between 0 to 1? Yeah, this type of questions you may get it, because you may think that how they at least ask about the ReLU functions. So we learn about ReLU. Let's take the options. ReLU is the A and B is the Tanh and C is the sigmoid and D is softmax. So we never talked about the softmax. So answer D is we can eliminate, and ReLU, Tanh and sigmoid. So we learned that sigmoid has 0 to 1 and the Tanh has -1 to it's a positive 1, and the ReLU, which is 0 to whatever the positive number, so the same positive number as is, right? So the answer is a sigmoid. The answer is C. Sigmoid maps values into a range between 0 to 1 and it is useful for the probability, right, based on the predictions. Now let's get into the next one, which is next question. So why are activation functions necessary in deep learning? Now, to reduce the training data size, to improve the storage efficiency, or the next C is to allow the networks to learn complex problems, right? To D is to eliminate the hidden layers. So the correct answer is, we know that to allow networks to learn the complex problems, that's where the answer, direct answers. So without activation functions, we said that okay, deep neural networks behave like a simple linear models, right? So now get into the question number 4, which is which activation function is most common used in modern deep neural networks? We learn about this. Today we learn about the sigmoid, Tanh, ReLU and linear. Out of these three options, especially sigmoid, Tanh and ReLU is the mostly widely used activation functions, right? So ReLU is computationally efficient, trains faster, and it widely used in the modern deep learning systems. Now let's get into the next question, which is the question number 5. The machine learning engineer is building a deep neural network for the image classification. Which activation functions would most likely to be used in the hidden layers? See, look at this, how they are asking the questions. So now we should understand that. So the answer options is ReLU, linear, sigmoid and none. So none means none of this one. So now the answer is, we know that ReLU. So ReLU is commonly used in the hidden layers because it is efficient and helps deeper networks in the train faster, right? So one tip I'll give you for the AWS exam tips. So you are unlikely to calculate exact activation functions value in the exam, right? The focus on the concepts. Okay, sigmoid, we learned this one. Sigmoid output 0 to 1, Tanh output -1 to 1, and ReLU output 0 to positive infinity, whatever the number as is, right? So and ReLU and the activation functions add non-linearity. So this is where we should remember this one. And now from key takeaways, right? So takeaways. So let's quickly summarize. Activation functions introduce non-linearity. That's first question. The statement we learn about it. And without them, neural networks behaves like a simple linear models. That's one. And sigmoid output values 0 to 1, and Tanh output values between -1 to 1, and ReLU output 0 for the negative values, and it keeps the positive values unchanged. ReLU is the most widely aimed activation function in the modern deeper learning systems, and choosing the right activation function depends on the problem, the data, and the model architecture, right? And most importantly, activation functions helps neural networks learn complex real-world problems. Now let's do the conclusion. Today we learn one of the most important concepts, deep learning, right? The activation function. We understood why they are needed, how they add the non-linearity, and how Sigmoid, Tanh, and ReLU work. We also reviewed AWS AI Practitioner style questions to prepare for an exam. It's everything. We gave the key points as well, key takeaways as well. We discussed about the key takeaways as well. Now that's all about this topic. In the next episode, we are going to learn training versus inference. We will understand how AI models learn during trainings and how they make predictions during inference, right? In this video, if this video is helpful, please like, share, subscribe, right? Thank you for watching. We will see you in the next episode.